Welcome to homework.
So in this question, first we need to figure out the current that is going through the circuit. So if we say that the current is, so that's a loop. So if we say that the current is going clockwise direction, that means in this where it's going this way, in this where it's going this way, for this where it's going this way, and for this where it's going that way. So if we say that the current is going clockwise direction, then we can apply our Kirchhoff's loop rule. So here we cannot apply the junction rule because there's no junction here, but we can apply the loop rule and then we solve for the current. So let's apply the loop rule using Kirchhoff's law. So what happens? So we start with this one. So here, since the current and the direction that we took are the same, so there will be a negative sign. So it's going to be negative I times 2.0 ohms. Then for the battery, it's going from negative to positive, which means it's a potential gain. So that's a positive sign. Then if we go in this direction, again, the current and the direction of uh, the loop direction that we chose are the same. So that means it's a negative. So it's going to be I times 4.8. Then here it's going from positive to negative. So there's a potential uh, drop. So it's a negative again. For this, again, there's a potential drop because current and the loop direction are the same. So it's going to be, it's going to be negative I times 1.0 ohms, and the total thing should give us 0. So if we solve for I from this expression, we get I equals 6 volts divided by 7.8 ohms, and that gives us our current through the circuit as 0.769 amps. Now we know our current, so we need to find the terminal voltage. So the terminal voltage for each battery, we can find that by summing up the potential difference across the internal resistance and the EMF. Okay, so for let's do this one, and for our calculation we're choosing the direction from left to right. So again, to rephrase our terminal, to get our terminal voltage, we should find out our potential difference across the internal resistance and the terminal and the battery from left to right. So for 18-volt battery, if we do it from left to right, our V terminal will be negative I, because the direction of the current, negative I times 2.0 ohms, and then there's a potential gain because it's from negative to positive, so we'll have positive 18 volts. So if we put the value of I here, we get our voltage as 16 volts. And for 12-volt battery, again we're going from left to right, but notice that here the direction of the current and our direction, which we took as left to right, are opposite to each other. So that means it will be positive. So it's going to be I times 1.0 ohms, and then there's a potential gain over here because it's going from negative to positive again, so it's going to be 12 volts. And if we solve for it, we get our terminal voltage as 13 volts. Again, we're putting I from here. So the direction we chose for this is left to right for both of the cases. Thank you.